Pete Yost here for the Unbuild It podcast with a word about our sponsor, Huber Engineered Woods. There are really three reasons why I think Huber Engineered Woods stands out, and it's a big part of why they're a sponsor of our Unbuild It podcast. First, they develop systems of products. The products are compatible and integrated. Makes our jobs a lot more easy in the field and when specifying. Second is superior tech support. There are really good website resources that they have developed for the application of their products, but they also have an outstanding 800 numbered tech team that really knows their stuff. And the last is a really active technical research and development team with whom I've done a lot of work over the years, and I have a lot of faith in the information I get from them when I have questions about product performance. So that's it. That's our high performance sponsor. Now on to the podcast.
I'm Jake Bruton, and welcome to the Unbuild It podcast. On today's podcast, we're going to talk about acoustics in residential buildings, and we are going to stick to residential, right?
Pretty much,
That's where
yeah.
we normally do.
And I want, this is about acoustics, so Steve, listen very carefully. Get it? He's giving me...
Okay, moving on.
I'm listening very carefully.
So there you go. There's the introduction to the two that are joining me today. The usual suspects, Steve Basic. Yep, still listening. And Peter Yost.
Still smiling. That's Steve.
So when we decided on the topic of acoustics, there were multiple things that came into mind. Mm-hmm. Number one is, what am I hearing from outside the house while inside the house? Number two, what am I hearing from room to room inside the house?
Yeah.
And then three, what are the things that are making the noise that I'm worried about inside the house? So let's start with the inside to outside thing.
Got it.
So I think it was you that told me about a noise reduction program up north someplace near an airport or something. Do you remember this story?
Yeah. And the cool thing is that they were doing noise abatement on homes around airports and creating moisture problems at the same time that those were looking into the air tightness of homes for energy reasons were finding moisture problems. So it's kind of neat that, energy moves, heat energy moves through air in various ways through conductance and convection, and sounds the same way. You have the movement of sound waves through solids that's conductive acoustical energy moving through the system, but you have air leakage waves that are called flanking pathways that are contributing too. So at the two separate programs, one trying to manage noise, the other trying to manage energy flows, we're experiencing some of the same phenomena in their work, which is pretty cool.
So as we talk about, I always talk to people about air sealing, like you can build a 12-inch thick wall, but if you leave the window open, that's the same as air leakage all over the wall. Yeah. That completely applies to sound in buildings. If you leave the darn window open, you're going to hear what's outside.
And we did some testing at the research center on, once again, ICF buildings, because they were, talking about how much better they were or isolating sound. And it turns out that the air tightness at all the penetrations and the types of windows became the weakest part of the assembly. So you can't just go after sound like you can energy in one area. You have to have a comprehensive package to go after it.
And so now that I've been in my personal house for a couple of years, we have 2x8 walls, we have exterior insulation, we have triple glazed windows from Europe, we have incredible air sealing. I'm really proud of our efforts, and it is so quiet that in the middle of the night, I no longer hear the neighbor shut a car door. I hear a cat walking down the hallway that I wouldn't have heard at our last house, sort of thing.
Yeah.
So now we have the inside problem to deal with. But is there other things that we can do on the exterior envelope besides air sealing and insulation that regular residential construction can make an effort to cut back on sound?
Well, I think the other big element of this is that high mass, absorbs quite a bit of sound. Now you could say, well, yeah, but if I have a real thick concrete floor and someone's walking in very hard-heeled shoes upstairs, so that's another type of, which is the transmission through large masses by striking force, so another type of sound we have to be guarding against. But certainly from the inside to outside, high mass walls do really great because they absorb, the vibrational energy that's creating the sound.
And so we should get out of the way the one that I hear all the time when people talk about sound attenuation, either in between rooms or from the outside in. Well, why don't we just spray foam it?
Yeah. So what are the properties of spray foam that help with sound? Well, if it's airtight, that's going to help quite a bit. It's not going to contribute nearly as much to the mass effect, although it does dampen sound waves moving through it for sure.
Some, but not as good as, say, a fiberglass that's properly installed might, right? Like there's an argument to be made there that sound is nothing but a vibration, and that vibration can transfer through things, and you have to get thicker and harder and heavier than a certain point for that to be the correct thing, rather than it's going through a wall and it's transferring through studs and whatnot.
Yeah, I mean, I think there's a lot of ways to skin this cat, but you've got to go after conductive and convection. Conducting sound and air leakage, just very similar to the way you go after energy control. Yeah.
No comment from you, Steve? Okay.
I'm just listening very carefully.
Well, we're going to ask you, how do you incorporate acoustic considerations in your designs?
But not yet. We're not asking that yet.
We're holding that in reserve.
So let's move inside now. I'll take the lead on this aspect and talk about how we deal with sound inside homes most of the time. It's been a long while since we built a house that had a movie theater in it. So my sound attenuation stuff is more, I don't want to hear people in the bathroom. I don't want to hear my wife in the kitchen while I'm in the bedroom, things like that. So we have a rule of thumb system that we use where if the wall has plumbing in it, it gets insulated. If the plumbing is coming to an end, it has an arrestor on it. So like our washer and dryers have hammer arrestors on the top of them. If the floor is a living space above a living space, we try to insulate between the two whenever possible. So second floor living room, or a living room and then a basement living room, something like that. We don't generally ask people to insulate between the master bedroom and the living room because the kids aren't staying up without the parents. So there's never going to be, in general, not never. So we try to choose wisely where we insulate, because we can't just throw insulation in every single wall inside the house. It would be nice if we could.
Yeah, it would be nice if we could. Yeah.
But some of the other things, we've put cork pads underneath washers and dryers before to try to isolate the resonance of that thing. Whenever we have traditional ducted units in our houses, we use metal pipe because metal ductwork is a little more efficient with airflow, but we give a soft boot between the register and the main duct run so that we get a little less vibration noise. Let's see, what else do I have on my list? Oh, one of the things that we always have a conversation about is bath fans. If we are putting a traditional bath fan instead of like an ERV in, sometimes we'll go, okay, well, the house is going to be really quiet. Would you rather have a noisy bath fan for privacy noise? Like, would you rather have a little bit of noise in this instance, or are we still looking at how quiet a fan we can buy so that nobody can hear it?
That's really interesting, because the two reasons the one reason that people give for bath fans, particularly kitchen range hoods, for not running it is, it's too noisy. So Energy Star bath fans have a SON rating, because people tend to run them if they're quieter. I think if you're looking for privacy, you're probably going to do that. I would like to see that accomplished by something other than the exhaust fan,
like closing the door.
Yeah, or like I like to sing. Do you mind if I sing a song that I usually
Don't mind me. I'm just listening carefully.
But But we have that list of things that, like, it's written into our scope of work that we're going to put hammer arresters on. We ask for, when possible, we would like to make a transition in some of our houses to using cast iron if we have a drain line running through the middle of the house from second floor down. We haven't yet, just because we've gotten so much pushback from our plumbers saying, well, we don't want to do it like that. No other argument other than we don't want to do that. But you could make a difference off of material choice.
Yeah, I mean, you walk into a front foyer that's two stacked open, and there's all hard surfaces, and it's like entering a museum or something. There's so much sound feedback. And I think, there's homes are becoming much more open in terms of interior layout, which is good for a whole lot of reasons, but acoustical separation is a big deal. Steve, how, in terms of inside-outside noise and inside-to-inside noise, how does that affect your design?
Very interesting question.
I think that's his way of saying, can you repeat it? I wasn't paying attention.
No, I was paying attention. I was listening very carefully. So the first thing that comes to mind is a lot of people come to me and they say, oh, we want a really open plan. And I say, okay, do you understand what that means, really? Just to understand. Because a lot of people, they think they want it until they realize that they have to put their TV on 30 to get over the clanging of the pots and pans in the kitchen to actually hear something. So that's the first concern, is when you say open plan versus somewhat compartmentalized, what's happening there. A lot of the energy efficient features, because like you had said, acoustics are so well tied to air leakage or air movement that if you solve for air tightness, you virtually solve for a large portion of acoustical nuisance, right? But the one thing that does happen is, like Jake said, I've done a passive house, and the guy had brought his old refrigerator into the new house. He had to throw it away.
Clicky, 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 clicky.
He's like, I never heard those noises before.
Now
and now it's the only thing I hear, and it's so annoying I have to get rid of it. But a couple other things come to mind. I was recently out in Coronado, San Diego, and I was with a builder there, Shane from Patriot Homes, doing a beautiful job, by the way, Shane. And he had a 2x6 plate with staggered 2x4 studs, outside, inside.
Yeah.
So it was a double wall on there. And I was like, wow. I've heard about this. You don't see it much from energy efficiency. He goes, oh, it's not for energy efficiency. It's because the flight line is right overhead. So there's a naval air station right there. And I mean, while we were there, planes were like every few minutes, there was something going overhead. So, I mean, half the island, I'm sure they're military-based people anyway, so they just live with that noise.
Yeah.
But one way that he battles it is by building this, what in a sense is a very energy-efficient wall, but it's acoustically efficient.
Yeah.
One of the reasons I like Tremco acoustical sealant on the outside. I mean, think about it for a second. I'm applying all of my sheathing to the house on a bead of acoustical sealant. So the conductive noise, I tell clients, I just keep it simple and say, to me, there's only two kinds of noise: the noise that goes through it and the noise that comes around it.
Yeah.
Right? And so the noise that goes through it, if I put an acoustical bead of sealant and I basically separate everything from the outside face of the stud frame via an acoustical bead, that becomes a very, very silent house.
Are you speccing acoustical on the middle of the panel too?
No, we put it around the perimeter of the panel and around the any openings. So, or top and
quite a few.
I say usually it's like top and bottom and around any openings, which is a large portion of it. But then the builders will get carried away and they'll start putting on every stud or every joint of the panel and carrying it through. One of the recent projects that we're just about to go to construction with has an interesting problem that I think I found the solution, but I'll have to report on it later. They have a commuter rail that runs through the back of their house. that
Through the back of their house?
well, not through.
That doesn't sound safe.
Please
Yeah,
listen.
but they have a stop right there.
Please listen carefully, and please do not interrupt.
I was listening. That's why I understood
you
the language
interrupted
choice
very
that you
abruptly.
made. Sorry, I was shocked.
He wants you to have like an arrestor as part of your comments.
So the train runs on the rails just behind the property line
That makes
of
more
their
sense.
residence.
I'm with you.
Okay. All right. But anyways, commuter rail on an hourly plus schedule goes 6 cars racing by at, 30, 40 miles an hour, whatever it does. But it shook the house. And he asked, he goes, is there anything I can do about this?
Move.
I would suggest
Move.
putting acoustical sealant along the rails for that stretch by your house. How's that?
So that's why you do what you do and I do what I do.
I thought move was a decent suggestion too.
Clearly you have another idea.
He is
Share with
moving.
us.
No, he is
Okay.
moving. He's
Okay.
just moving to the lot next door. So he bought that house. We tore it down and we're going to build a new house. But come to find out, I found I think it's a 1/4 inch and a 1/2 inch a neoprene acoustical sill sealer.
Oh, cool.
So we're going to put the whole house on this
On a
half
rubber
inch
pad.
half-inch
Yeah.
neoprene pad to isolate any of the ground vibration to the house.
Very interesting. Now, that brings up an issue, which is, when they do the STC, the sound transmission class, the problem is that the way that longer, lower wavelength sound moves through can be quite different than stopping high frequency. So, you have to sort of protect against all of those different wavelengths, and that's not easy to do because some
So
get
it's
through.
funny you should mention that because I have a story about that too.
Nice.
So come to find out, we did a zero energy passive house inspired house a number of years ago, like 4 or 5 years ago. One of the problems we were having is when the mini split would start up, it's at a different frequency than when it's operating.
Oh, interesting.
Right?
The outdoor unit.
Yes, the outdoor unit.
The cassette.
And come to find out, the homeowner took it upon himself. He's a smart guy. But when they set the outdoor unit, he went out and got these larger rubber grommets than what came with the unit. And so they put it on there. Well, the problem when when the machine kicked on, there was this low-lying hum in the house. And it would be for like the first 30, 40 seconds, and then it would go away. So
once the compressor got up to
once
speed.
the compressor got up to speed. Now, what he learned in talking to the Mitsubishi engineers, or what they came out or understood, is that those rubber grommets that he bought from Granger or whatever, they actually have frequency spectrums.
Yeah.
And that you can tune them to different frequencies.
Yeah.
And the grommets that he had bought were outside of the spectrum
Interesting.
that startup was operating at.
Huh.
And so he went and he got the right ones and the problem went away.
Yeah.
So
Another interesting example of that is if, and this came out from the noise abatement programs around airports, that if it's dual pane glass and or glass with a storm, the way to stop more sound transmission through if you have two pieces of glass, there will always be a wavelength where the spacing between the glass ends up to be an amplifier. So you'll go through the sound spin, and when it gets to that frequency, all of a sudden you'll hear that sound because it's reverberating between the two spaces. So if you're going to try to catch all the frequencies, the airspace can't be equal between the 3 panes of glass in a 3-pane system, because otherwise you'll get a amplifying effect as opposed to a dampening effect.
Because it comes in, hits the center, goes back to the first one, and so it's ping pong effect, and they start to pile up.
Yeah, essentially, it's like creating a drumming effect, because at that one wavelength it reverberates as opposed to being dampened.
Except for I've never seen that I'm aware of different size spacers used in a triple pane.
My recollection
window.
is there are special glazings for acoustical abatement that do exactly that. They have small differences in the spaces to catch all the frequencies.
So the last time that we had any conversations about acoustics with clients, they own like a 6,000 square foot house. They rent the main level to some friends of theirs, and they wanted to renovate the downstairs for them to live in as an apartment. And so it had tall ceilings in the basement. So we underframed under all the floor trusses another ceiling that had like the minimum of attachment points. Mm-hmm. And the clients were being their own designers. And he said, we're going to put almost 3 feet of cellulose between us and the people upstairs. And I was kind of like,
3 feet of
yeah.
cellulose. Wow.
I was like, that's a hell of a lot of weight to add to the floor system, first of all.
8,000 pounds across the floor. Crazy.
And I was like, I guess we can do it, but I don't know what it's going to do to the building, and I can't be held responsible for what it's going to do to the building if you're not willing to look into other options. Like if this is the only choice that you're saying you're willing to pay for. And so
it's like a rodent dream too, right?
Yeah.
Because you can chew through that,
3 feet
through that, and you can be in the middle of that, all snug and cozy, man.
And so we basically just said, like, you're agreeing that this is not our problem if we do this. And we finished, and it was February, and like 3 weeks after he left, after we were done, he called and said, well, we have a hose bib out front that broke because it was buried in so much insulation that it was literally only accessible to the air leak around the pipe to the outside. So it had no heat getting to it, where previously it was an unfinished basement.
Yikes.
Where all the heat from that basement was getting up to it. And he pointed at me, and I went, our entire conversation was, I don't know what this is going to do to the building because I've never done it before, and we don't have an architect or an engineer involved, so I can't be responsible. Do you remember that? He was like, well, that doesn't seem like this was something that should have been. I was like, okay. So
unintended consequences, he signed up for them, right?
Adding insulation may not be the right answer always.
I thought you were going to say that the problem was footfall because wherever there's a framing member, it's sort of like doing a exterior wrap with insulation, right? You need to put in a thermal break. You kind of need to bring in an acoustical break because at the framing, you're going to get that transmission.
Yeah, and so 3 feet of insulation, you could still hear the people walking on the upper layer.
Yeah, I mean...
that's because you took care of the noise that went around it, not through it.
Exactly.
Yep. Exactly.
Buddy, you're onto something here.
I'm glad he decided to pay attention.
It's it's funny you should say pay attention, so I got a joke for you.
Your phone's ringing. Now he's not paying attention because he's trying to figure out how to make his phone stop ringing, in case you couldn't hear that.
So, my dogs, they're very smart. I've been trying to teach them math.
Your dogs are very loud.
No, I was trying to teach them math. So I had Goosey sitting there, and I said, Goosey, what's 2 minus 2? He said nothing.
That's the best dog joke you've ever told.
In a long string of dog humor, is that what you're saying?
Yeah.
He said nothing.
That's very good. He said nothing.
Goodness.
You kind of covered that in Toto. Doggone it.
Now we just get Pete's rebuttals.
Look, you throw the dog a bone.
I'm sorry. I'm going to choose to not participate in this.
We'll just play amongst ourselves.
You go right ahead.
So I do want to give a shout out. There's a mechanical engineer in northern Canada, Robert Bean. He's now retired, but he has a website called Healthy Heating, and his
is this Pete's resource?
No. Actually, This is not going to be my resource. Well, it's a subsidiary resource, but his website, Healthy Heating. I think it's healthyheating.com. He, as an engineer, has indoor environmental quality broken down into thermal, acoustical, visual, olfactory comfort. And he actually has a separate one called vibration, which is for transmission noises. And he said if you want to provide people with a good indoor environmental quality, you have to go through after all of those. which is kind of neat for a mechanical engineer to say that, hey, it's not just about thermal comfort. It's about all around comfort. So, and he's got a lot of great resources on his website, including, I believe, for acoustical, but very cool engineer, very broad-minded. You'd like him as an architect.
So let's talk products real quick as we wrap this up. Mm-hmm. And rather than make recommendations, because there's tons of stuff on the market that have all sorts of different things, can we take everything that we just said and try to apply that to products? We're looking for things that reduce vibrations, and we're looking for things that cut off pathways for the sound to travel from an air standpoint.
Your hands, would you still be able to talk?
Sorry, they move a lot when I talk, for those of you that are watching.
That was Jake picking my nose, apparently.
But is that a good way to say it?
No, because I don't know what you said.
Because you weren't paying attention because you were watching.
No, we apply what we just talked to in our selection of products.
So when we go shopping, can we say, does it stop a vibration, or does it stop a sound wave traveling through air? Like, can we just go, okay, we're looking for these two things, and then we have to decide what the appropriate choice of those two is, or if it's both? Like, can we have a product that does both?
Yeah.
Because we could stand here and go, oh, well, they make a product called Quiet Rock.
There's a lot out there. It's one of those things that I found is, when people say, oh, well, we want to make that very acoustically efficient. And it's like, it's one of those things that when you do finally get into it, you realize that the budget usually outweighs the desire.
Almost always.
Almost always.
Well, I think
right, because they make drywall with like thin sheets of like metal sheets inside it that are acoustical panels and all this stuff. But when you're paying $40 a square foot or something for these panels to line a room, you sit there and say, do I really need that? Do I really care about the people on the other side of the room? And blah, 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 blah.
Yeah. Or we did we had a audiology clinic that we did some work on for the people that own the building, and we had to assemble this test room where we literally put a room inside of another room, and the only thing was that the room we built inside touched on 4 rubber pads on the floor. Yep. That was it. Well, there's your room for your movie theater in your house. Let us build a room inside of another room that they don't communicate. Well, there goes your budget.
Yeah.
Yeah. I remember back in college that we went to this very prominent university in Cambridge. And
are we purposely leaving the name of this institution out? Okay. So as to not wind up in another institution?
Yeah. So, but we went into this one room. So they I don't know, acoustics laboratory or whatever. But they had this cool room. Like you went in, and there were these conical formed walls.
Anechoic chamber?
That were like 14, 16 inches.
Yeah, they're really amazing.
And you couldn't have a conversation with anybody in there. It was so acoustically efficient, you couldn't hear somebody. It would just take all the sound.
They're very spooky.
It is crazy.
You're supposed to be able to hear your blood flowing.
You can hear your blood flowing in your body if you're inside by yourself, the loudest is your body functions. Yeah.
Yeah, it's really.
So told you can do the same thing with PCP and LSD mixed together too. You can hear your hair grow.
Unbuild it podcast. Okay. You hear your hair grow. I find them relaxing, but a lot of people find them disturbing. I like it. I like those padded rooms with the. Well, no, that's something else.
Mostly when you spend the weekend in them.
Disturbing.
72-hour hold, is that what they call it?
72-hour hold. But I think the big takeaway for me is you control sound an awful lot how you control, heat flow. So the same rules apply. Isolate things, especially hard surfaces. I think when we just moved into part of our new house, the acoustics of an empty room with a hardwood floor where all 6 surfaces are hard. Holy smokes! You get down in the basement where there's a drop ceiling, so there are acoustical tiles. And there's carpet on the floor. It's like being in a whole different world because you just get all that sound absorption.
The other thing as a builder that we have to keep in mind is when someone walks into a job site and says, "Man, it's really echoey in here." Well, it also doesn't have a rug or 2 couches and curtains hanging on the wall. It will be different once you move in.
when actually I'm going to close out with a resource coming from Building Green, but when I was in an office there, one of the offices had sisal on.
I don't know what sisal is.
Sisal is a natural fiber, but it's like burlap, right?
Okay.
Well, since it had a lot of varied surfaces, it was wonderful acoustically. So that when we, as a side benefit of this new, very attractive natural material wallpaper we had, everybody said, oh, that's going to have to be Peter's office, because when I talk on the phone, they say it's like the whole company hears Peter on the phone, because I, get very excited and talk to him. Yeah. So I got the sisal room.
Anybody would say that.
Because it was acoustically more absorbent.
So let's wrap it with Pete's resource.
So Pete's resource. So when I was at Building Green, I wrote an article called Building Green Quietly. And I went back and checked it. The publication's still up on their website.
Wow, after 65 years.
Yeah, funny how sound travels.
They scanned his parchment, and now it's on the website.
Scanned the parchment. You guys.
Reinterpreted the Latin.
I told you, once you are old enough that it is completely inappropriate for us to make fun of you about your age, we will stop.
You'll stop.
Are we in agreement that it's time to stop?
But by then I won't really care, will I?
No, somewhere in England there's a whole bunch of monks going, that Peter Yost guy was really smart, as they're translating.
So, and I just realized that it's possible that article is behind the Building Green paywall. So if anybody has trouble getting it, just sign up for free weeks, or
I thought you were going to say,
send the email
me
to Peter at buildingright.com, and I'll make sure you get a copy.
I think everybody should just email Peter and say, can we get a copy of that article? I'd love to see his inbox.
And do you know who the first two requests are going to come from?
These two guys. First two?
I'm definitely emailing him today.
Can I put it on?
There actually is a noise pollution clearinghouse, which is part of the resource list in the article, but it's good. I went back and made sure that it was worthy of the Peter Yost resource column. So, buildinggreen.com.
Okay. Thanks for watching on the podcast today. Don't forget to click like and subscribe and the little bell button so you get a notification when we publish something new. If you're listening, if you're just using your ears and not using your eyes, that means you should go to iTunes and leave a 5-star review so that other people can find out about the podcast. Until next time, Steve Basic, Peter Yost, I'm Jake Bruton. Thanks for watching. Have a good day.